Good morning, grade 10. We are going to check this exercise that was given as homework. So here we have to add forces. In this case, they are not collinear forces. They don't have the same line of action. So we have to go through the parallelogram way. I'm going to name these vectors AB and CD. To find the net force, so first of all, I will bring AB here. We are solving this exercise graphically. Then I will take the point of application of this vector, this is C. I will place it in B. And I will take the vector and put it in here. So this is D. This is also C. Now, the net force in this case is AD. You have to complete the parallelogram, as we said. So if you complete the parallelogram, AD is the diagonal, this is the net force. In the second case, I will name them also AB, C, D. This is AB. This is the ending point. I will put in it the starting point of the second vector, which is D. So I will hold this vector and put it right here. So now, this is D and this is C. When you join them, you'll get the diagonal of the parallelogram. This is the net force. And finally, I have AB, CD. This is AB. And CD, I'll place C in B. This is D. I will join them. This is the net force. Of course, if you complete the parallelogram, you will get the diagonal. If you complete the parallelogram, you will get the diagonal. Thank you. This is the last exercise in the homework sheet. We are going to find the forces acting in each case. In the first case, I have an apple falling through the air. The first question is, what are the forces acting on this apple? So I have two forces. The first one is gravity. By gravity, I mean the weight of the apple. Any object on the surface of the earth is attracted by the core of the earth. And the second one is friction, and you know it also as air resistance. The second question is, we have to compare the sizes of these forces. Since the apple is going down, what's pulling the apple down is the gravity. What's trying to stop the motion is the friction. So the apple is going down, which means the size of the gravity or the weight is larger than the size of the friction. So gravity is bigger than friction. And finally, we have to draw the diagram. So this is the weight of the apple. Vertical going down, it's equal to m times j. M is the mass of the apple, and this is equal to 9.8 meters per second squared. And we have the air resistance, which is trying to resist the motion, but it's way smaller than the weight. So this is for the first situation. In the second one, we have a ball hanging on a string. What are the two forces? It's also gravity. This is the weight of the ball, which is equal to m times g. And we also have, in this case, the tension. Whenever we have spring or string, we have a tension. This tension is also vertical, but it's going upward. The question is, we have to compare the sizes. So if the ball is at rest, it means that these two forces are equal in size but opposite direction. So T equals minus W are talking about vectors. So they are both vertical, one's going down, the other is going up, they have the same size. This is why I don't have the motion in here. In the final situation, I have a book resting on a table. The two forces acting on the book are gravity, which is the weight of the book, the center of gravity, the weight is the force always vertically going downward, it's equal to m times g. And we also have normal force. Normal force, it's the force that exists between any object and a surface. So just because the book is resting on the surface of the table, we have a force the table is applying on the book. It's always perpendicular to the surface. We have to compare their sizes as well. In this case as well, m equals minus w. Because the book is resting on a table, it's not moving, which means the forces are balanced.